Okay, so what we're going to talk about today is this fundamental theorem of calculus. And then tomorrow, we probably won't get into this average value and mean value theorem until tomorrow. I didn't get to that in any of my other classes, so I think even if we have time, I'll probably not do that till tomorrow. So we first start with this theorem, theorem 4.5, the definite integral. So far, all we've done is indefinite integrals. The difference between indefinite and definite is how you have these bounds right here, this a and this b. Okay, so if you have a function, continuous, non-negative, and the key here is there's a closed interval. Okay, so I'm not just saying, what's the antiderivative of this thing? I'm saying, okay, hey, we're talking about the antiderivative between these two numbers. Okay, then really what we're talking about is the area of the region bounded by the graph of f, the x-axis, and then two vertical bounds. Okay, so like in general, A here is for area, and we have bounds A and B, where A is the smaller number, B is the bigger number. We're going to integrate that function, and then later on I'm going to show you how to actually plug in those numbers. Okay, so for this first one, it just says set up a definite integral that yields the area of the region. Okay, so first of all, we write our integration symbol. Then we have to decide the bounds. So look at the graph. What do you think our lower bound is? -2. Okay, so that we would write that down here at the bottom. Okay, and then our upper bound, b, would be 2. All right, just using this kind of thing right here, f of x, that's going to be this equation. So 4 minus x squared. And since that's in terms of x, I'm going to put a dx there. All right, this statement right here represents this area. Now, before today, like thinking way back to like last week and even before, how did we estimate this area? What do we call it? Riemann sums. We did left Riemann sum, right Riemann sum, midpoint, trapezoid. And if you just cut this up into shapes, we could find an estimation of that area. That's what we did when we did Riemann sums. And what I'm going to show you today is how to find this area exactly. Riemann sums, though, are still important because we also did Riemann sums with tables. This is an actual equation, okay? To do what we're going to do today, we couldn't do that with a table. We have to have an equation to do what we're going to do today. All right, so let's talk about a few properties, and then I'll show you how to actually compute that. So first of all, if you have, if you're trying to do an integral, a definite integral, where these two things are the same number. So like, for instance, if we were trying to do something from 2 to 2, or we were trying to do something, even if the number was weird, 11.7 to 11.7, it does not matter what the function is. That is going to equal 0. Why, like, geometrically would that happen? Like, look at the, there's no area in between. You just have a vertical line. And a vertical line is infinitely thin. There's no thickness, there's no area. If you start and stop at the exact same point, there's no area, okay? That's why so this is like a really fun, for me, test question, where I put a really, really, really difficult integral, then I put the same number here and here. And if you know what to do, it's a really easy problem. If you don't know what to do, you kind of get frustrated and mad at me at the same time because you might end up doing too much work. So that's 0, all right? All right. Also, we have this thing where I've kind of already hinted at this, but if you have an interval a to b, where a is the smaller number and b is the bigger, excuse me, b is the bigger number, that's how intervals generally go. Do you see here how we have the small number on top and the bigger number on the bottom? Like, if we switch these, basically if A goes here and B goes there, either way, the difference is it brings out a negative, okay? So imagine it this way. If we were to scan the area, like if we had like a camera and we scanned from A to B, and I said the area is 7. It's not 7, but we'll just say it's 7. Okay, imagine now if we scanned backwards from B to A. What would you imagine the answer is in that case? What's the backwards opposite 7? -7, okay? And so when these numbers are in opposite places, we can correct that because we like to have the smaller number on the bottom, like how it is over here, okay? So like if you have the smaller number on top and you're like, no, that's not really how we like to write this, just switch them and then multiply the whole thing by a negative. Either making the result negative, or if the answer was negative, you put another negative, it could make it positive. But in the end, the difference is one's negative, one's positive. Okay, this is going to make more sense kind of as we go into this next part, but I wanted to at least introduce it. All right, here's the next thing. We have a function. I didn't say this in the last one, but integrable just means that you can integrate it. We can't integrate everything. We don't know how to take the antiderivative of everything. And so that has to be true in order to say these things are true. Also, if we have a function that is non-negative, that means that everything is above the x-axis, like our example here. In that case, the integral will always be positive. It could be 0. All right. So the idea is, well, what if f is not non-negative? What if it is negative? Then what do you think the integral would be? So can we integrate it? Is it still positive? Is it negative? We're going to answer that on the next page. Okay, but I'm just kind of putting that out there. Like if this isn't true, will that change that second part? All right. All right. Everybody prepare to be wowed. Are you ready? Okay. The fundamental theorem of calculus. This is a big deal. This is kind of like the biggest deal. It doesn't mean it's the hardest thing we're going to do. It's actually, most students find this theorem a lot easier to remember than the other theorems because it doesn't really, it's more like a rule, okay? So the fundamental theorem of calculus, we will do a theorem write-up on this later. So just keep that in mind. And so here's what the theorem states. If we have a function that's continuous, and again, it has to have a closed interval, okay? That's important. And we say capital F is the antiderivative. That's what we kind of called that at the very beginning when we did this. Then the whole integral, which I know geometrically is the area under the curve, that is between the curve and the x-axis, is the same thing as, okay, find the antiderivative, plug B in, then subtract that from plugging A into the antiderivative. So it's more like a formula than a theorem, really, okay? So what I want you to do first is let's just rewrite the problem that we had at the top. And now we are going to go ahead and solve this out by hand. And then we're going to kind of remind ourselves how to do it with the calculator. So if these numbers were not here, okay, so for a minute, just pretend the numbers weren't here, we would find the antiderivative, capital F, right? And we know how to do that. That's what your quiz tomorrow is over. So what's the antiderivative of 4? 4x, right? The derivative of 4x is 4. So the antiderivative of 4 is 4x. If you've forgotten about how to do the next one, remember we do minus, leave a space for it, excuse me, any coefficient, write the x, and with derivatives we subtracted 1, so for integrating, remember, we add 1, and then you take the reciprocal of the 3 and you put it right there. So what I've just done is review of what 4.1 is all about, okay? So the first step is just doing what we already know how to do. Now normally, what would you put after this? Plus C. And you need to really remember that for tomorrow's quiz. Plus C. We are not going to write plus C on this. Okay, and I'm not going to tell you why. Instead, I'm going to have you tell me why when we're done with this problem. Okay, what we're going to do instead is we're going to draw, that really should be vertical, so let me draw that again. we're going to draw a vertical bar, okay? Sometimes teachers or professors may use brackets here. I'm just going to use a bar, but just know that if you looked in a book, another book, or if you had a tutor, they may put this whole thing in brackets. And I'm going to put it at the end, and I'm going to put the same numbers, okay, 2 and -2. All right, what this signifies, you know, the dx went away, right? So what this signifies is that, okay, I have taken the antiderivative, but I still need to plug these numbers in, okay? And all you got to do is you plug the top number in first, so in place of x, so we have 4 instead of x times 2 minus 1/3 times 2 cubed. That's what this big F of b, that's what I've written here. I've written the antiderivative with the top number plugged in. Okay. Next in the formula or theorem, we have a big minus. And because of what I'm going to write after the minus is more than just a single item, I'm going to open up a set of parentheses so that it's clear that I'm about to subtract everything that I write next. Okay, now what number do you think I'm going to plug in? The -2, okay, the lower number right here. So 4 times -2 minus 1/3 -2 cubed. And then I'll close those parentheses. All right, this is your answer, by the way. So here's the deal. On the AP test, on a free response part, you can leave your answer just like this. But this is probably actually going to be on a multiple choice part, in which case the answers will be simplified. For me, for my test that y'all are going to have on Tuesday, here's what you just need to follow directions. If the directions just say evaluate the definite integral, you do not have to simplify. But if I say specifically simplify all the way down to a one number answer, like, and we'll talk about this, but it'll say that, okay? Or if it's multiple choice, you have to simplify down until you get the answer, which means a little bit of number crunching. It's not bad, but this is something you need to be able to do quickly and accurately without a calculator. Okay, so we are going to practice it a couple of times today, and then you're going to have some homework, but I'm not going to kill you with this stuff. I'm not going to give you like a million problems to do. All right, so this is a good answer, but like I said, if this was multiple choice or something, we would need to be able to go further. All right, so let's go ahead and practice this one together. 4 times 2 is 8. On the next one, 2 cubed would be 8, and so that would make that minus 8 cubed. All right, and then I'm going to go ahead and do this -8 and distribute the negative at the same time, so that's going to make plus 8. And then this piece over here is going to be, I don't know why I put a negative right there. I don't know if y'all noticed that. That was a mistake. There we go. So -2 cubed should just be -8. Times a -3rd would be positive 8/3, but it's negative minus 8/3. So you got to be able to do some number crunching. But you guys know how to do this. You just don't want to do it. I get it. But you do know how to do this. Okay, this is not simplified down to one number answer yet. So I'm thinking I want to go ahead and add the 2 8s, 16, and combine the 2 -8/3. What would that make? Minus 16/3. And so we're closer, but we still don't have a one number answer. So how do you add two numbers if they don't have the same denominator? You got to get a common denominator. So I need to change that 16 into something over 3. So what would 16 be? 48/3. You just do 16 times 3. Some people can do that in their head. Some people have to go off to the side and do the scratch work to figure it out. All right, 48 minus 16, that is 32. And so 32/3 is my final answer. Okay? So 32/3 is the exact answer to this area right here. And notice that that is a positive number. Okay? Now, we already know how to do this in our calculator, but let's just kind of like review it real quick. I'll change this to green. Okay, I'm not going to pull my calculator up on the screen because I've already showed you guys how to do this. But remember, you in your home screen, and I'm going to encourage you all to get your calculator out and to try this now so that you're able to do it.
So you don't have to do that.
Correct. But you need to practice it so that you're not doing it for the first time like on a quiz or something. That's going to eat up all your time. All right, so in the home screen, you do the F3, and you select option 2, and it puts the little integration symbol. You can also do second 7 if you want to remember that. All right, and then it opens up the parentheses. Now, remember, you're going to first put in your function. So 4, and in your calculator, you're going to need to do this. 4 minus x squared, comma, remember what goes next? Comma x. Now, let me say this. If you were to close parentheses, I have not yet showed you this. If you were to close parentheses right now, it would give you this right here. All right? So it does indefinite and definite. All right? But I want you to be able to do both of those without the calculator. But we're not going to do that right now. We already were able to do that without a calculator anyway. We want to go ahead and actually do this whole problem right here. Okay, that's what we're doing in the calculator. So I'm going to do comma, -2, comma 2. You got to do lower bound, then upper bound, then close the parentheses. And if you press enter, you will get 32/3, which is what we got by hand. So when you're kind of doing this on your own, you got your odds, the answers in the back of the book, but you can also check any answer you want with your calculator.
My calculator, when I click the X, it doesn't have what's
It has a totally different menu.
It has solve and X, Y, and solve.
Okay, I'll look at your calculator in a minute. For now, see second 7. Do you see it? Okay, so for now, just do that. But your menu is different, but I'll have to look at it. I always forget how to change that. But then, because you've done differentiating on your calculator before, right? Yeah.
Yeah.
Okay, because that's the same way. It just got changed. Some kind of option got changed. All right. So let's move on to the next page. All right. So here's a new problem. So, this says evaluate. It's the same thing we've been doing. So what's the first step? Whether the numbers are there or not, it's the same first step you always do, which is finding the antiderivative. So the antiderivative of -3x, the way I kind of showed you guys before was to go ahead and put -3. If you're not sure if there should be another number here, put a times, leave a space, write your x, and what would be the new power on x? 2. And what's the reciprocal of 2? 1/2. So you don't have to just do guess and check, like, what can I take derivative of to get -3x? If that works for you, do it. If not, then you can do this process. All right, what about the antiderivative of +4? Plus 4x. All right. Ew, I keep forgetting this all day. Go back really quick. I'm sorry. Why did we get to leave off plus c? I told you guys I was going to ask you and then I forgot. Why do we get to leave off plus c? That's okay. Yeah, but like, look at the problem. Let's say I had left on plus c. What would have eventually happened? Like if plus c was right here, then where else would it be? Right here, but also right here. Do you see how, let's say plus c was +7. You would have a +7 here, And then you would have a minus plus 7. You see how it would always cancel? Always. So it's okay technically if you write plus C, but I will tell you, you will never see that in a book or in a calculus class. It's considered to be not good, poor taste. It's not necessary. So when you're doing these closed interval, definite integrals, don't put the plus C, in other words. Yeah.
Well, with the interval or whatever, wouldn't you not have the C anyway because, like, it couldn't be any number? So
You're very correct. Because we have this closed interval, we kind of get trapped into what even our antiderivative is. So that's a totally different way of looking at it. But no, and if we looked at this geometrically, there'd even be another reason of why. But either way, don't put the plus C when you have the numbers and you're going to plug the numbers in. Okay, so back to this one before I forgot. Okay, so we don't have the plus C, right? We put the bar, and now this signifies that I have found the antiderivative, and now I'm ready to plug in 5 and 2. And so I'm going to go ahead and do that. Negative 3 times 1/2, 5 squared, plus 4 times 5, minus, remember after the minus you need to put a parenthesis because you're about to subtract more than one thing. You need to make sure that you understand that, and that's what the parenthesis means. Now, even though you'd rather not, I want you to go ahead on your own and try, and this one's actually easier, I think. I want you to simplify this down all the way to a single number. Let's go ahead and go over this one. So you should have gotten negative 75 halves for that first chunk, plus 20. All right, and then what'd you get for the next one? Plus 6, minus 8. All right, so whether you go ahead and get a common denominator now, whether you put that into a decimal, whether you combine these or whatever, you should have gotten negative 39 halves. That is the final answer, which is negative, which is interesting. Because we talked about the whole non-negative thing, and look, the 2 and the 5, they were in the right spot, so that's not the culprit. So we got to think, well, why is my answer negative? Okay, over here to the side, I want you to make a quick sketch of this graph. Okay, this is a line, right? Y equals mx plus b. Okay, 1, 2, 3, 4. And then we go down 3 over 1, down 3 over 1. So it's a very steep line, okay? And like 1, 2, 3, 4, 5. And so it's very steep. And the area that I'm looking for is the area between this curve and the x-axis. It's always between the curve and the x-axis. In this case, the line and the x-axis. In this case, between 2 and 5. So here's 2, and here's 5. So look at where that area is. The area itself is positive. Area can't be negative. Area is kind of like speed, in the sense of like speed versus velocity. Area, always positive. An integral, though, can be negative. So now that we've seen this problem, we've done this problem, when you have area that is below the x-axis, what does that tell you about that thing's integral? It's negative. Okay? So when we have an area that's above the x-axis, that's a positive integral. When we have an area that's below the x-axis, that's a negative integral. And we didn't have to know that ahead of time. It worked out just fine. So that's the good thing. We don't have to like figure it out and then account for it. It just works out, whether we do this in our calculator or by hand. Okay, so looking at the next one, This problem doesn't say anything about an integral, but it is an integral problem, and how do I know that? What are like the keywords here?
Find the area of the region bounded by the graph.
Area of the region bounded by the graph, the x-axis, and then they give us our a and our b, basically our closed interval. Okay, so the picture on your paper is a little bit better. There's your a and your b. Here is your curve. Here's the x-axis. What this is asking for is this area. So without doing a whole lot more, can you tell me if this integral is positive or negative? Positive, very good. Okay, so first we're going to go ahead and write the integral. It'll be 0 to 2, 2x squared, we write the function next, and then dx. Okay, we know how to do this in the calculator. We're still going to do this one by hand, but we're not going to crunch the numbers on this one. So we take the antiderivative. I'm going to, just for time's sake, I'm going to go ahead and go through this one like with you. So 2 times, leave a space if you need to, write the x, add 1 to the power, and I'm kind of doing this just to kind of help review everybody for tomorrow's quiz. Yeah?
For these, does it mess it up if you like were to simplify like 1/3 x cubed first and then
Like make this 2/3. Oh wait, sorry,
like,
say that again?
or make it like 2x. Wait, no, you couldn't do that. Like if you made it 2/3 without like.
If you made it 2/3, that's totally fine, because it means the same thing. Yeah, that's fine. All right, and so like this one, I'm going to go ahead and write 3. I'm going to leave the space. My new power on x is going to be 2, and then I'm going to put a 1/2. If you had written this as -3/2, totally fine. It means the same thing. All right, and then the last one would be plus 2x. So again, we don't need the plus c, but we do need to go ahead and write our bounds, our interval, our limits of integration. There's a lot of different ways we can describe that. Okay, so this is good. You need to go one more step. Even like the cheap way, you got to go one more step. And that is you got to show that you're plugging in 2 and 0. But we don't have to actually crunch the numbers. And so if we do that, we have 2 times 1/3, 2 cubed, minus 3 times 1/2, 2 squared, plus 2 times 2. Okay, so that's the whole first chunk. Minus. Now, look at what do you think is going to happen for the next chunk? Like if we were to multiply it all out. It would be, the whole thing would be 0. You have like high confidence in that? Yeah. So you actually don't even have to write that. You can just write you can write a single 0, or you could actually not write it at all, you know, but I'll go ahead and write it just to show that we did it. All right. Or you could write the whole thing out by plugging 0 in. That would be accurate as well. So this is a perfectly acceptable answer. It's not simplified, but this is acceptable on the AP test and on my test, unless otherwise said. Okay. In case you were just wondering, because it was like killing you, that this simplifies to 10/3. All right. The very last problem we're going to consider is this one right here. F of x equals x squared minus 6x plus 8. And there's a reason, there's something I want to do on this, but first, let's look at what it says to do on part A and what it says to do on part B. Read those directions for part A and part B. Are they the same? Are they different? Are they different, but they mean the same? What do you guys think? Not sure? They're worded differently, but they kind of mean the same. So it would help if we saw, I'm going to show you that there is a slight difference between the two, but I'm going to show you by drawing the picture. Okay? And I'm going to tell you that B is really how we want to see this. So we could go through how to graph a parabola. I'm going to do what I think is the easiest way, which is to find the zeros. Okay? We find the zeros, by factoring, and I'm just going to kind of use this over here. So this is x minus 2, x minus 4, and we set it equal to 0, right? So we get x equals 2 and x equals 4. Those are the zeros, aka x-intercepts. So in the graph, 1, 2, 3, 4, 5, we have right here. Those are the two places where this parabola is going to cross the x-axis. Is this parabola facing up or facing down? Up, right? Because the leading coefficient is positive. And so this parabola looks something, that's a horrible picture, but it looks something like this. All right? That's what that parabola looks like. I could be more detailed and I could find the vertex and I could find the y-intercept. Okay, whatever. We're running low on time, so I'm not going to do that. All right. There are technically kind of 3 chunks to this integral. This chunk, and this chunk. Okay? Do you remember what I said about area? Area is always what? Positive. Okay, area is always positive. It's kind of like integral is a vector of area. Okay, area is always positive. But the integral, it has a sign, and we know that because this is above positive, below negative. So if we did the integral, we could either do it by hand. Okay, we could do it, so we could do this by hand. We could do this in the calculator. Okay, I'm not going to do one more example because I think we're good on examples at this point for today. But it works out the same way the other problems worked out. Okay? However, look at what this says. Find the total area enclosed by the graph of f and the x-axis. If that's really what you were wanting to be asked to do, you would have to break this up into 3 pieces. And this negative piece, you would have to make it be positive. In other words, you would kind of have to do something like this. All right? You want to know the beauty of integration, though? You don't, in integration, you don't have to do that. Okay? I want you to really understand this concept. All right? But I don't want you to worry about right now about how you're going to have to apply it. I just want you to understand that integration is area, but area itself doesn't have a positive or a negative. It's just, it is positive, we'll just say, neutral or whatever. All right? But when we do the integration, it does all this, it does exactly what we need for us. Okay? So it's a good thing that it works out for us. All right? Do you all have questions? We'll talk more about this, but in the gist of what I want you to really get is that when you're doing an integral, what it will do, the process, either by hand or the calculator, it finds the area above the x-axis, and that's a positive, and then it subtracts the area below the x-axis. Okay? Right there.